Okay, so in this lesson we're going to start looking at how we would actually solve these type of equations, a polynomial equation. So far we've been adding and subtracting, and we've dealt with multiplying, and now we're going to look at how we would actually solve these equations, start that process. So I want you to try the warm-up. When you think you have all the answers, unpause the video and we'll go from there. So now that you've had a chance to try them, all you're doing is pretty much foiling. You'll notice in 2 and 3 that my exponents didn't come over correctly, but that should be the quantity 3m minus 2n squared and 2m plus 5 squared. But anyway, the first problem, we're just going to go ahead and factor. So I get y squared. My 8y's are going to cancel, and I get negative 64 at the end. For number 2, all I'm going to do is I'm going to expand it out. It's a negative 2n, so that I can see both of the binomials. So 9m squared plus negative 12mn plus 4n squared. I'm going to do the same thing for the last one. So 2m plus 5 times 2m plus 5. So 4m squared plus 20m plus 25. So as I stated in the warm-up, we're going to be looking at how we solve these factored equations. It's actually a 2-day lesson. The first day we're going to look at some basic equations, and we're going to start looking at a process that we're going to need a little bit later. And then the second day, we're going to kind of put the examples from the first part of the lesson, put them together for the final piece. So here all we're talking about is the zero product property. And the zero product property states that if you have any two things multiplied together and you get an answer of 0, one of the two things you must have started with is 0. Because the only way to multiply two things together and get 0 is if one of them was 0. Think about it. There's no other way to multiply any two numbers and get 0 unless one of them happens to be 0. And that's the property we're going to be using to kind of help us along today. So the first thing I have written out is I have the steps written out. We are solving equations. We need to make sure our equation is set equal to 0. If it's not, we need to move things around, but the right-hand side of that equation always needs to equal 0. Then we're actually going to use that zero product property, split it into two smaller pieces, solve each of the pieces, and then as always, we are going to check. We are going to be ending up with two answers for each of these problems, so we are going to have to do two checks, one for each answer. So in this first problem, you'll notice that it does equal 0. So I'm going to take it and branch it literally into two smaller problems. So x plus negative 4 equals 0, and x plus 2 equals 0. To move my negative 4 to the other side, I need to add positive 4. So one of my answers is x equals 4. Positive 2, I'm going to add negative 2 to the other side. So my second answer is x equals negative 2. Pretty straightforward. 1, don't overthink these. And 2, make sure you're thinking enough. Don't just rush through, because that is the easiest way to make sure you miss some of your signs. Going to check them, I'm going to check the x equaling 4 first. So both parentheses, everywhere I see x, I'm plugging in 4. So 4 minus 4 times 4 plus 2 needs to give me 0. 0 times 6 needs to give me 0. 0 equals 0. Checks are pretty basic right now, and I understand that, but we need to get in the habit of doing them. Just like when we solved 1- and 2-step equations and I made you check and you were all like, why? Because eventually we got, excuse me, to 6 or 7-step problems, and that check came in helpful. So I'm going to check the other answer, the negative 2. So negative 2 minus 4 times negative 2 plus 2 needs to equal 0. Negative 6 times 0 needs to equal 0. 0 equals 0. My answer checks. There are 2 of them here for you to try. So now that you've had a chance to try them, I'm going to go over the answers to them. I'm not going to show the checks just for the sake of time, but if you need to see the checks, as always, please make sure you let me know. So I'm going to change to plus the opposite. Split this into 2 smaller problems. So x plus negative 5 equals 0, and x plus negative 1 equals 0. Move the negative 5 to the other side by adding positive 5, and we get x equaling 5. I'm going to move my negative 1 to the other side by adding 1. We get x equaling 1. My 2 answers are 5 and 1. These 2 answers are not ordered pairs. It's not an x and a y, so you cannot put them together. You literally just circle or box in each separate answer. Down here we have x plus 3 equaling 0 and x minus 5 equaling 0. Add negative 3 to each side. So x equals negative 3. Add 5. X equals 5. So this is the second part of today, the first lesson that I was telling you about, and it deals with factoring out the greatest common monomial. If you remember, a monomial is a number by itself or the product of a number and variable together. And greatest common factor is the largest number that both things can be multiplied by, or the largest number that you can divide both things by. So I'm getting ahead of myself a little bit. Let's just step back, take our time, and look at this first problem. You're looking for the largest number that you can divide into both 12 and 42. And the largest number that goes into both 12 and 42 is 6. Basically, we're undistributing, is what we're doing. So 6 times what in the parentheses must have given me the 12x? Should be 2x. 6 times what would have given me 42y? And that would be 7y. And that's all we're doing right now. We are just undistributing. So your answer is going to look like another problem. Down here, start with the numbers first. The largest number that will divide into 4 and 24 is 4. Now we do have variables that match. We have x's. And you'll notice this first monomial piece has 4 x's, and the second one has 3 x's. How many x's do they have in common? They have 3. There are 3 x's that I could pair up. 3 pairs I could make. So 4 times what? 4 times 1. I have 3 x's outside. I started with 4, so I must have 1 left over. 24 divided by 4 is 6. I had 3 x's. I took 3 out in front. I have no x's left. So the x's, or our exponents, are more like subtracting. Because if you remember, when we did exponent properties, instead of dividing exponents, we subtracted them. So it's the same process here. So I want you to go ahead and try these 2. So in the first one, largest number I can divide both of them by is 4. I'm working ahead of myself. So 8 divided by 4 is 2, the x comes down. 12 divided by 4 is 3, and the y comes down. And the second problem, it's not right. So we have a 14 and a 21. The largest number I can divide both of them by is 7. There is 1 y in common. That leaves me with 2y plus 3 left over. So here I just have some simple equations for you to solve. I'm going to give you a few minutes and then I'm just going to go over the answers to each one, but if you have questions on how I got any of those answers, go back and relook at that first example. Remember, we're just splitting the problem into 2 smaller parts. So for the first one, you're going to have x equaling positive 5, and you're going to have x equaling negative 3. I'm not putting parentheses around that, so it's not an ordered pair. I'm just using the comma to separate. In the second problem, you would have gotten 13 and 14. Problem 3, don't let the fraction scare you. You get 7 and you get negative 4/3. 4 is positive 3 and negative 3. For number 5, we get negative 11/3, and we get negative 1. And for the last one, number 6, we end up with negative 5/2. Remember, we do not use decimals, and we end up with positive 5/7. So now we're going to practice the greatest common factor, pulling out that greatest common monomial factor. Again, try it on your own, and then we'll go over it together. So in the first problem, we have the 2x plus 2y. The only thing they have in common is 2. That leaves us with x plus y inside, or 1x plus 1y if you have the 1's written there. In the second problem, our numbers actually have nothing in common, but there is one s in common. So it's going to leave us 3s to the third plus 16. Number 3, we're going to pull out a 7, and we're going to pull out 2 w's. That's going to leave me 1w cubed plus negative 5. Between 15 and 25, my common factor is 5. There is one n in common. That leaves me 3n squared plus 5. And this lovely fraction one down here. So we have a 5/2 and we have a negative 1/2. They have a 1/2 in common, and they have 2 x's in common. Oh, I'm sorry, they have 4 x's in common. So that would be 5x squared plus negative 1. Oh, no x at the end, so just plus negative 1 at the end. Homework tonight, basic worksheet. The worksheet's really going to factor on this common monomial factor that you need to pull out, the undistributing. If you have any questions on that undistributing, please come see me because it is a crucial piece to where we're going in the second half of this lesson. So for the second half of the lesson, the warm-up entails pulling out that GCF. So go ahead, try it on your own, and then if you have any questions, I'll go over the answers then. So in the first one, between the 20 and the negative 4, our common factor is 4. Oh, don't want my parenthesis quite yet. So the 4. They have one x and one y in common, so that leaves me 5xy plus negative 1. In number 2, the 8 and the 6 have a 2 in common. There is one a and one b in common. It's going to leave me 4a plus negative 3b. Number 3, I have 3 pieces, so I need to figure out what I can pull out of all 3 of them that they share. Well, all the numbers can be divided by 2, and they all have 1g in common. So that is 1g to the third plus 7g plus 3. Last one, between the 6, the 21, and the negative 15, I can pull out a 3. There are 2 q's in common, so q squared. So that gives me 2q to the third plus negative 7q squared plus, dividing by 3, so that would be negative 5. Looks like there's another warm-up depending on which one I chose, so I'm going to go ahead and go over this one as well. I'm going to factor out the GCF in the first problem, pulling a 2 out. That leaves me with 1x plus 1y. In the second problem, I can pull out a 7w cubed. That will leave me with 1w squared plus negative 5. Number 3, I can pull out a 5n. That will leave me with 1n squared plus 5. And the last one is 8s to the 4th, so I can pull out an 8 and an s. That leaves me with, can't divide today, that leaves me with 1s plus 2. So now we're going to look at the steps to solve a factored equation. The only thing that I have added from yesterday is steps 2 and 3. We actually have to look and see if there is a GCF. And if there is a GCF, we need to pull it out. And by pulling out that GCF, that's what's going to allow us to split that problem into 2 separate pieces. So in the first problem, we're going to look for that GCF. In this case, it's going to be a 2x. So that's going to leave us with x plus 4. And we haven't done anything with that equals 0. Just like when we had the double parentheses yesterday, we're going to split this into 2 pieces. So we have 2x equaling 0 and x plus 4 equaling 0. Divide each side by 2. X equals 0. Add negative 4 to each side. You have x equaling negative 4. Checking both of your answers, please make sure you check in the original problem, okay, not the one where we've already pulled out the GCF. So 2 times 0 squared plus 8 times 0 needs to give me 0. Well, 0 plus 0 needs to give me 0. 0 equals 0. 0 checks. Checking the negative 4. So 2 times negative 4 squared plus 8 times negative 4 needs to give me 0. Order of operations is exponents first. Please remember that because we have a negative base, we have that negative 4. We need to make sure we're plugging that into the calculator if we need to, in parentheses, to get us the positive 16. Plus negative 32 needs to equal 0. Positive 32 plus negative 32 needs to equal 0. 0 equals 0. We are good to go. So here are 3 for you to try. If you believe you're okay and want to try them on your own and just turn the video back on, go ahead. If you want to listen to the explanation, I'm going to go through that right now. So in the first problem, I can pull out a GCF of 3x. And that leaves me with x plus 6 equaling 0. So 3x equals 0, and x plus 6 equals 0. Divide each side by 3. X is 0. Add negative 6 to each side. X is negative 6. I'm not going to do the checks for the sake of time, but if you have questions on them, please let me know. Biggest thing is you need to remember to plug back into the original equation. So in number 3, I can pull out an A. So that's going to give me a plus negative 5 equaling 0. When I split that into my 2 equations, we're going to end up with basically just a equaling 0. And we're going to end up with a minus 5 equaling 0. Add 5 to each side. And we get a equaling 5. So 5 and 0 are our 2 answers for the second one. Last one, I can pull out a 3x. That's going to leave me with x minus 3 equaling 0. So 3x equals 0. Divide each side by 3. X equals 0. And x minus 3 equaling 0. Add 3 to each side. We get x equaling 3. So 0 and 3 are our 2 answers for that last one. These particular problems we're just looking at because they're not set equal to 0. Everything up until this point, our equations had been set equal to 0, but now they're not. So the first thing I have to do is move the piece from the right to the left by adding the opposite in order to get it to equal 0. So I'm going to add negative 15n to each side. So it's going to give me 6n squared plus negative 15n equaling 0. I'm going to pull out my GCF. From here on out, it is just like the last example. So I'm going to pull out my GCF of 3n. That leaves me with 2n plus negative 5 equaling 0. So 3n equals 0. Divide each side by 3. n equals 0. 2n plus 5 equals 0. I'm going to add negative 5 to each side. 2n equals negative 5. Divide each side by 2. n equals negative 5 halves. And again, at this point, we all know how to check. You would plug it into the original problem. You'd plug it into that 6n squared equals 15n. So in number 2, we have 4x squared plus negative 14x equaling 0 because I moved that 14 over. I can pull out a 2x, leaving me with 2x plus negative 7 equaling 0. So 2x equals 0. Divide each side by 2. X is 0. And then we have 2x plus negative 7 equaling 0. I'm going to add 7 to each side. 2x equals 7. Divide each side by 2. X equals positive 7 halves. And again, we don't write decimals. So in the third problem, I'm going to bring that 2x over. So we have 4x squared plus negative 2x equals 0. Pull out a 2x, and that leaves me with 2x plus negative 1 equaling 0. So 2x equals 0. Divide each side by 2. X equals 0. 2x plus negative 1 equals 0. Move the 1 over, it becomes positive. So 2x equals 1. Divide each side by 2. We get x equaling 1 half. These are a whole bunch of problems for you to try. Honestly, for the sake of time, we're not even going to worry about them. If you want to try them and check them, you are certainly more than welcome to. But if you're listening to this just kind of as a refresher, you don't necessarily need to worry about doing them. If you're listening to this because you were absent and you're trying to get caught up on the notes, for this particular slide, please come see me in class because chances are we did not do all 12 of the problems. And if you're watching this because I'm not here today and there's a substitute in my room, then by all means, you were supposed to do all 12 of the problems. Homework tonight, the traditional worksheet like always. If you have any questions on anything you saw in the lesson itself or on your homework, as always, please come see me.